We are live. And anyone have any questions on this lesson?
I had a problem just with the preparation assignment just because I couldn't find the information for the questions. Any idea where those were at, other than the video on?
I watched the video a few times.
What's that?
I watched the video a few times. This one's talking about baseball averages.
Yeah, but I mean, for question one, it says classify each of the batting averages as either unusual or not unusual using the z-score to make this determination. Where did you find the mean and the standard deviation for that?
Sorry, wait, you're talking about the homework quiz for this section?
Yeah, the preparation for this. The preparation assignment.
Oh, so this isn't like the lesson 5 homework quiz. That's not what you're talking about.
No, I'm talking about the lesson 5 prep assignment.
Sorry, 1 second.
Okay, we're going to go hop into that.
And then it's question number...
No, that's just question 1. I didn't
So they have 0.19, 0.225, and they want you to say if that's unusual or not usual, right?
Right.
And
my question is I know how to figure those out if I have the mean and standard deviation, but where are the mean and standard deviation? Was that hidden in the reading somewhere? Was that another page I missed, or?
It's because I mean, maybe I misunderstood how this works, but how to explain this? I think it has to do with what the z-score is. I don't think you need to have the mean. Am I wrong?
Yeah, because the mean is what will tell us how far away from, in order to calculate the z-score, you need the value that you're given. For the first one would be 0.19 minus the value of the mean, which we don't have, all divided by the standard deviation, which again, I didn't have for that. Now I used the Excel spreadsheet file to get that information, but it didn't match the answers in the answer sheet.
Nope.
Will, do you have any ideas on this?
I'm looking for it. It sounds familiar. So when he talks about it, no, it would be in that video.
Okay, I found it. It's in section 3.2.2, gives us the mean, and 0.034 is the standard.
It gives the what?
It's in the reading. It's just hidden in there. So it's in section 3.2.2, baseball averages. It says the mean for this problem is 0.261, and the standard deviation is 0.034. So.
Now we just have to start with this first one and say if it's... Does that answer your question, though? Are you good?
Yeah, I found the answer.
All right. Go ahead. I'll let you take it.
Okay, so I guess I'll start us on this first. Were there any other questions in relation to the preparation assignment?
No, I think when we get to the questions, I'll be able to ask some good questions. I took this class up until about this far last semester, so some of this stuff is like refreshers that I learned like 3 or 4 months ago. We'll see what happens.
Okay. All right, so question 3. The total area under a normal distribution curve must equal 1.
Yes.
Correct.
Yeah. Because that represents the entire probability, right?
Yep.
It's kind of like 100%.
100% of all of your answers will be underneath that curve.
So the next two
Yeah.
answers, isn't it false and true? False and true. It's
Well, let's read the questions and answer them. Yeah.
Under certain circumstances, the normal distribution curve can drop below the x-axis. False.
That's false.
The normal distribution curve is symmetric. That is true.
awesome. So sometimes when I took this class I took it in the winter semester. My group never read any of the questions out loud, and so by habit, I just read them real quick, and then I'm like, okay, let's answer it.
Yeah.
Yeah.
I like reading just because it helps make sure we're all on the same page.
No problem.
Yeah, and that's fine. I'm trying to get over that habit. And so awesome.
All right. Brad, do you want to read the next information in question?
Are we at number 6?
Yep.
Which of the following segments of the feature represents the z-score? I choose C because it's more than it's pointing at the arrow at 1.
Agreed.
1.000.
Yes, sir.
And in the applet, that's where you put in your z-score stuff.
And then I'll read question 7. Which of the following elements of the figure represents the probability that the z-score will be greater than 1.000? And I have B.
B.
I'll read this one. According to the 6895-99.7 rule, what percentage of the data from a bell-shaped distribution will be within the standard deviation of the mean? Write your answer as a percentage such as 42 rather than a proportion such as 0.42. So, what percentage of the data from the dell? Are they talking about the one above?
This is any distribution curve, or
Yeah.
Um,
Oh, okay.
any what's the right?
So that would be the 68?
Any normal distribution curve. Yeah, it's the 68.
Quadrant 1.
Yeah. So if you have the mean and you go one standard deviation to each side of it, that's 65 or 68% of all your values.
Yeah.
One more deviation is 95%. The next one is 99.7%.
Yes. Okay.
All right, I'll read this one. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of z-scores will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. Okay, so this should be about 68%, but we'll want to put it in the official.
Is it talking about this?
Yes, sir.
Okay.
I got 0.683.
I got 0.68. Let's see. 3 decimal places? Yep, 0.683.
And is everyone okay with like understanding how the applet works? And
Yeah,
don't
let
be,
me pull it up. So, what is Z-score? To answer the question. It's not going to be 0.3173?
no, and this is actually what I'm glad you did you said that. I'll share my screen here.
Okay, let me.
Can you guys see everything? Do you see the applet?
Yes. Yes, I can see it.
Okay.
Yes.
Cool. So what I did was down here in the z-score area, I just typed -1 and press enter, and then it makes it so on both sides it's going to say the -1 and the 1. And normally what you probably see is it's like this. But what it's asking is what's inside in between those two. What's from between -1 and 1 right here. And so this blue shaded area is going to give you the 0.683. If it was saying what's less than 1, we would show you all of that and it would give us 0.84.
Okay.
But that was something I just wanted to, I know I had a hard time getting that at first, so I wanted to share that.
Awesome. Thank you.
So the next question is similar, but it's between -2 and 2.
Would that be 955?
Yeah, 0.955.
Yeah.
Okay, same thing, but just different z-scores, right?
Yep.
Yes.
And if you look, the 68, 95, and 99.7 rule is a close approximation. So when we're within the first deviation, we have 68.3. When we're in the second, we're at 95.5%.
Okay.
And then question 11 is 0.999.
.999?
That's what I got. Yeah, that's what you guys got.
I got
I got
0.7.
I got 0.997. That's what I got on my screen.
Oh, maybe. Oh, I must have it. I did. I have that small area shaded. You're totally right.
9972.
So I put for the number 12. It says, look carefully at your answers for the last 2 questions. What do you observe? And it's what you just said. The 90, 68, 95, 99.7 rule.
Okay, cool.
You guys agree?
Yep.
I mean, he already answered that, I guess.
All right. Use the following information to answer the next 6 questions. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body weight. The population mean protein requirement for adults is 0.65 grams of protein per kilogram per day. And the population standard deviation is 0.07 grams of protein per kilogram per day. So what proportion of the population have a protein requirement that is less than 0.60 grams of protein per day? Okay. That was a lot of extraneous information for just the bare numbers that we need. Does everyone know how to do this?
is it point 0.65 minus 0.6 divided by 0.007 for the first part?
It's the other way. 0.6 minus 0.65.
Oops.
Because it's the value you have minus the mean.
Divided by 0.07.
Yep.
So you get a negative number. Is that right?
Yes, because it's less than the mean.
Yeah, negative 0.7.
What was that, Daniel?
I got negative 0.714.
Yep, me too.
I don't understand that at all. So you're taking the requirement for adults and in the population that has the requirement less than 60 or 0.6.
Give me a moment. So we'll see. I'll share my screen real quick and we'll see if. So our z-score is determined by your, what was it? I'm going back to the book real quick to make sure I'm getting the symbols right. So value that you have the question about minus the mean, which is given by you, all over the standard deviation, which is sigma. So the idea is we have our standard distribution curve. Here's our mean, and our mean is 0.65, right?
Uh-huh.
And we have a value over here at 0.6. And the question is, what proportion of the population has a... Okay, I think we might need to go a step further. This will give us a z-score. So 0.6, in order to get how many standard deviations away this is, you put in 0.6, you subtract the 0.65, and you divide that all by 0.07.
Okay.
Then
So you came up with what did you come up with after you did that calculation?
after I did that calculation, I got negative 0.714.
Okay, that's what I got as well.
Okay. Then what we need to do is plug that into our probability applet.
Uh-huh.
So we have
As the area or as the z-score?
point as our z-score. Let's see, what was it? 714? So what proportion of the population have a protein requirement less than 0.6 kilograms per day? So here's our line for 0.6, and our proportion is everyone under that line, which is 0.238.
Okay, let me look at my applet and see if I got that right. 0.238, yep.
Daniel and Brad,
Thanks,
are you in
thanks for
agreement?
explaining that.
0.238.
Yeah, 0.238. Do you guys agree?
Just to make sure, that's number 13, right?
Yes.
That's what you got. Okay, just making sure we're on the same page.
When I plug in the z-score,
So it's
because are we going by the left side or the right side?
So the question is, what proportion of the population have a protein requirement less than 0.6, and so that would be to the left of that z-score. And since 0.6
That's
is
right.
less than 0.65, it's the z-score to the left of that. Left.
So then the next one is doing greater than 0.714.
Which would be the same, right?
It would have to equal 1. So what proportion of the population have a protein requirement that is more than 0.6? So you just shade the other side.
0.7624.
Yep.
0.762.
Oh, okay. So it's the exact opposite.
Yeah. It's just like our probabilities on the assignment before.
0.762, right?
Yes.
And is number 13 negative or positive?
They're positive because it's asking for the proportion or the probability of the population.
Okay.
So it has to be between 0 and 1.
Okay, that's 0.238 for 13. And 14, I got 0.762.
Yep.
Perfect.
So for this next one, we're going to do 0.7 minus 0.65 divided by 0.07.
Technically, yes, but if we can look at it, our other one, our last one was 0.6 minus 0.65, which gave us a negative 0.5.
Oh, yeah,
0.7 minus 0.65 is positive 0.5 or
Yeah.
0.05. And so we can use the same z-score and just go underneath it again. And I get the same as our last one, which is 0.762.
0.762. Oh, okay, yeah, because it's above. Oh, no.
Because it's beneath the z-score of,
Less than. Yeah, less than. Okay.
so I think I still have the probability on my screen. So we're looking at those two now.
It wouldn't be 238. Wouldn't it be 2?
That would be if we were asking for above 70. But we're asking what's less than 70 grams of protein.
Oh, I'm sorry. Yeah, so you shade in. Okay, yeah, okay. Thank you.
Yep.
Thanks for your patience.
No worries.
That's 0.762.
Yes.
Yeah, it's 0.76.
So that's for number 14, right?
Okay.
Yeah. So questions 14 and 15 have the same answer.
Oh. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70 grams of protein. Remember that to find the area between the two values, shade to the left of each z-score to calculate, and then subtract the smaller amount area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. And give it 3 decimals. We're taking the 0.762 minus the 0.232.
Yeah.
Oh no, not point. Is that right? 0.238.
238 should be.
That's all we're doing, correct?
Yep. Except
524. Oh, sorry.
That's what I got it.
I'm sorry. What were we gonna say? Except what?
it's just the way it wants us to do this. But let me tabbing between too many programs here. All right, so I'm still sharing my screen. It's this area that we want.
Oh,
Between
yeah.
the 65 and the 60 and the 70. But it's telling us to do it this way, so it probably wants the 524 answer instead of the 525.
Is it 0.525?
Wouldn't you round it up? So would it be 525 or 524?
That's the question.
I think
Because
it's
if we do it just by
525.
subtracting, yeah, let's do 525.
And
It is-
I'll submit beforehand and tell you if it's right or not. And then you can.
We have a second go around at this, so we can go through and fix
Really,
it again.
really, we have 8 tries if you think about it, because
Yeah, but that would take a lot of coordination and a lot of patience that I don't have.
We're saying 524 or 525.
I'm saying
525
525.
just to round it.
Is it 0.525?
Yep.
Yes.
I don't put in the zeros. I haven't this whole time, but yeah.
Okay. So find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimals.
I'm going to stop
35th.
sharing my screen, and I'll let you guys. Um,
I know it's 35%. 35%.
To be honest, this one's throwing me for a loop. What are you guys doing?
I'll be just a moment.
Let's see.
All right, I have an answer. Anyone else have the answer yet?
No, how'd you get your answer?
I'll share in just a moment. I just don't want to take away the opportunity for anyone else to hash it out.
9. Okay.
Daniel, Brad, how are you two doing?
I'm not happy.
I'm having a hard time calculating this.
Okay. I will start sharing my screen again. All right. So the first question is, what's the z-score for the 35 percentile? So we shade in the area to the left here, underneath this guy. Then we put in what we want, which is 0.35, because it's the 35th percentile, right?
Yeah.
So that gives us a z-score, but a z-score isn't the doesn't tell us the protein requirement. It just tells us how far away we are from the standard deviation. So from there, we need to work backwards from our equation.
is it 0.629?
I got 0.623.
Okay.
Let me see where it is.
Wait, so the part, so I get that we put in the 0.35 and we get the area. What's the next part from there? I think the point.
So when we get the area of that, the area is the 0.35. We want the z-score. So what's the,
0.05.
so the z-score is negative 0.385, right? If I'm repeating something you've said, it's because you cut out and I didn't hear you entirely. So
No worries.
So don't be offended if I say something, but
Not at all. I'm grateful that you understand it so I can learn it, you know?
okay, yeah. So this is what our equation becomes. We're looking for what x value we want. And so from this lower equation, we have to figure it out and solve for x.
Okay.
So that gives us negative 0.385. And then you multiply both sides by 0.07. And you add 0.65 both sides. And that gives us our x. Which means Brad was probably right and I somehow entered. No, wait, no. So
I got 0.0118. Negative.
So negative 0.385
Like that.
is 0.07.
Oh, I did the whole math. So negative 0.385 times 0.07.
I got 0.263.
Yeah, sorry, I had already solved that, the whole equation.
Okay. I believe I got 0.263 as well. Yeah, 0.623 is the answer I got.
0.623, okay. Oh.
Yep, 7. Yep.
All right, so then we have the same question again, but this time for 80%.
So I didn't hear you guys for like a minute. What did you guys get as your final answer for 17?
0.623.
I missed how you got the last part. I calculated. Yeah.
Okay. One of these days, I'll figure out everything and tap between things nice and easy. So this equation right here transforms into this equation below right here.
Oh, and are you adding those two things? The point.
So these two you multiply together.
Yeah, I did that. The part that I'm struggling with is that Why are you adding 0.65 to that? Why aren't you multiplying?
Because right here,
Never mind.
right here we have the subtract.
Whatever you do on one side, you do it on the other side. It's like a tiered toddler.
Yeah.
So 0.623. Yeah. Okay. Perfect. Now we just do the same thing, but
Yep. Now we do a similar thing with the.
Minus 1%.
hey, can you put your work back up there that you had before, Thomas or TJ?
Yeah.
Thank you.
In just a moment.
So I got 0.591.
I got 0.709.
Okay, question for you. Why are we doing 0.07 instead of 0.06?
Okay, one moment. So what was your question?
Why are we using 0.7 instead of 0.6?
So 0.07 is the standard deviation.
Oh, that's what I was getting confused with. Okay.
Yeah.
Let me see if I entered this in wrong. You got 0.842 as your z-score, right? Negative?
Yes, 0.842.
Positive or negative?
Positive.
That's probably where my answer's wrong. I put the negative for some reason.
So, what did you get for the question 18 then?
So for question 18, I got 0.709.
Yep, I got the same thing.
0.79.
709.
0.709.
Why is my numbers freezing up? Okay. That's right there wrong. Okay. 0.709.
So, what did you do on the probability applet this time?
So my probability
Did you
output, look, yeah. So this time we want to get the 80th percentile.
Yes.
So we're going to highlight the lower half, and then for area,
Yeah.
we're going to put in 80 or 0.8.
Okay.
That'll give us our upper z-score, which will be the 80th percentile. Then we just hammer out the math from there.
Okay, now in your paint, where you had done the math in the paint thing, it was like, let me think. What I put in was 0.842 times 0.07. Pretty much is all. Oh, plus the 0.65.
Yep.
Oh, I'm sorry. No. 0.05894 plus 0.65. And then I ended up with like 0.59 something. 0.591. I don't know. I just need to go back through it.
Give me just a moment. I'll be right back.
And for 17, you guys got 0.623.
Yeah, I got 0.623 and then 0.709.
Yeah.
Okay.
Okay, I'm back.
Are we ready to submit this thing?
Yeah.
I am. Are there any more questions?
No.
Because I
I
want
feel
to
good
grab
about
this so I can write things
Oh,
easier
man.
than in paint.
You're the man, TJ.
Good job.
So, is there one question we're worried about? Did anyone submit it yet to find out if we got it right?
I'll submit real quick. I'm pretty sure it's right. Yep, it's the 525. Sure.
Okay, so you got 100%?
Whatever it was.
100%?
Yeah.
Okay,
Submit.
so we're good until next Tuesday, is that right?
Yep, we're good until next Tuesday.
Don't forget to do your
Alright.
weekly course feedback, guys, once it's available.
Weekly what?
Weekly course feedback,
Oh, yeah.
Thursday, unfortunately.
All right. Thanks.
Yep.
I
So,
went ahead and put the links to both of these in the collaboration areas.
all right. So next week it's 5 p.m. Central or Mountain.
5 p.m. Mountain,
Before Pacific.
4 Pacific, 6 p.m. Central.
Okay. And we will be going over lessons 5 and 6.
6 and 7.
Or 6 and 7, right? This was 5. Okay. All right.
Cool.
All right.
Perfect.
See you later.
Yep.
Thank you.
Have a good one, guys.
Same to you.
Thanks.
Ah,